Your brain changes course at 9, 32, 66, and 83. If you are 31 and still do not feel like a finished adult, neuroscience has delivered the most dangerous excuse imaginable. A 2025 study reported that one major phase of brain wiring continues until roughly age 32. Somewhere, an unpaid bill has just been informed that adolescence is technically ongoing. The same research identified 4 major turning points across the human lifespan, around 9, 32, 66, and 83. Those ages divide brain development into 5 broad epochs. The internet-friendly translation is that your brain suddenly levels up 4 times, like a video game with extremely slow updates and no visible progress bar. That translation is fun. It is also not quite what the study found. Researchers at the University of Cambridge and collaborating institutions combined diffusion brain imaging data spanning birth to age 90. Diffusion imaging tracks how water moves through tissue, allowing scientists to estimate the paths of white matter fibers. White matter is the brain's long-distance communication system, connecting regions that need to exchange information. If gray matter contains many of the local neighborhoods, white matter supplies the roads, rail lines, and group chats nobody can leave. The full harmonization set contained more than 4,200 scans from 9 datasets. The topological analysis used a cross-sectional, neurotypical subset of 3,802 people. The researchers translated each brain into a network, with regions as nodes and estimated fiber connections as links. Then they calculated features such as efficiency, clustering, modularity, and centrality. Efficiency asks how easily information could travel across the network. Modularity asks how strongly the network is divided into specialized communities. Centrality asks which regions behave like major transport hubs. None of these measures tells you whether a person remembers birthdays, makes good decisions, or can assemble flat-pack furniture without entering a new emotional era. They describe the large-scale organization of structural connections. The team then used a machine learning technique to compress many network measurements into a 3-dimensional map. They tested hundreds of parameter combinations and traced how the average network pattern moved through that abstract space with age. Places where the trajectory repeatedly changed direction became candidate turning points. The strongest clusters appeared around 9, 32, 66, and 83. The first epoch ran from birth to roughly 9. During these years, the brain is not simply adding more wires like somebody panic buying extension cords. It is reorganizing. Some connections strengthen, others are pruned, specialized systems develop, and the balance between local and global communication changes. The study found a distinctive topological trajectory across infancy and childhood before a major change around age 9. The second epoch stretched from about 9 to 32. The researchers called this an adolescent mode of topological development because the network continued moving along a broadly consistent trajectory across those years. The architecture became more integrated and efficient, while central hubs played an important role. Around 32, this path showed the largest turning point in the entire lifespan. Does that mean a 31-year-old has a child brain and receives adult brain in an overnight software update? No. Adulthood is biological, psychological, social, cultural, and legal. Different brain systems mature on different timelines. People gain adult abilities and responsibilities long before 32, while learning and change continue long after it. The study examined one particular feature, the topology of structural brain networks at the population level. So the useful line is not, your brain becomes adult at 32. It is, the average trajectory of this measured wiring pattern changed most strongly around the early 30s. Less useful for avoiding chores, much better science. After 32 came the longest epoch, lasting to roughly 66. Network changes slowed compared with earlier life. The study described clearer increases in segregation and decreases in efficiency, with no other major topological turning point for more than 3 decades. Stable does not mean frozen. Your brain still learns, adapts, and changes with experience. It simply means the average direction of these selected network measures remained broadly similar. Around 66, the trajectory shifted again. This turning point behaved differently from the one at 32. The researchers found changes across the main combined components of network organization without the same clear reversal in individual measures. They suggested it could reflect a long transition or acceleration in age-related change. White matter integrity often declines more quickly in later life, and the brain's structural network can become sparser and more modular. Then came 83. Beyond this age, fewer network features continued to show strong relationships with age. That might signal another genuine phase. It might also partly reflect the smallest sample. Only 93 people were in the final epoch from 83 to 90. When your oldest group is small, statistical certainty starts speaking more softly. There is an even bigger limitation. This was mainly a cross-sectional study. It did not scan the same 4,000 people repeatedly from birth until 90, which would require astonishing patience, perfect funding, and several generations of researchers handing over the office keys. It compared different people of different ages. That can map population patterns, but it cannot show that every individual brain hits the same turning point on the same birthday. The data also came from multiple studies in the United Kingdom and United States, collected with different scanners and procedures. The team used statistical harmonization and ran sensitivity checks. None of the 4 turning points lined up neatly with a boundary between data sets, which is reassuring. Still, harmonization can overcorrect or undercorrect differences. Atlas choices, network thresholds, the dimensions used for the map, and the curve fitted through it can all influence where turning points appear. The researchers were unusually direct about this. The precise polynomial used to trace the lifespan path affected some detected points, although changes around roughly 10, 30, and 80 were fairly robust across many choices. The study also could not fully test differences by sex, and the healthy older adults included in imaging projects may not represent every older person. That makes the 4 ages landmarks, not appointments. You do not wake on your 9th, 32nd, 66th, or 83rd birthday to the sound of neural scaffolding being removed. The changes are gradual biological processes. A turning point means the direction of the average curve shifts around there, not that the brain performs a hard cut at midnight. Still, the study overturns one deeply sticky idea, that brain development climbs towards adulthood, finishes somewhere in the 20s, then begins one long, smooth decline. The observed pattern was nonlinear. Different organizational properties rose, fell, stabilized, and changed relationships across 5 broad phases. Aging was not childhood played backwards. Each epoch had its own network direction. That matters because the brain is not one ability with one expiration date. A change that reduces global efficiency might coexist with stronger knowledge, better emotional regulation, or strategies built through experience. Structural topology can relate to cognition, but a network metric is not a personality review. Your brain at 66 is not a worse version of your brain at 32. It is an organization shaped by a different phase of biology and a lifetime of use. The real wonder is that there may be no single finished brain. There are periods of faster construction, long stretches of relative stability, and later reorganizations. 32 is not the moment you finally become a legitimate person. It is the strongest bend this study found in one map of structural wiring. 9, 66, and 83 mark other bends, each with different evidence and uncertainty. So keep the viral hook, but upgrade it. Your brain does not grow up in one smooth line, and its wiring does not simply stop changing after youth. Across thousands of scans, researchers found 5 broad topological epochs separated near 9, 32, 66, and 83. They are not expiry dates or maturity certificates. They are clues that a human brain spends an entire lifetime changing the way its network is organized. If you enjoyed this strange little journey, subscribe and help us reach 1 million curious minds. There are many more weird facts hiding in plain sight, and we intend to bother all of them. The only question left is which one we bother next.